Now, after discussing the concept of probability and the relationship with sample space and events, we move to the next topic, that is called random variables. As we have already discussed, the random signals are non-deterministic signals, and the experiment based on these random signals are called random experiments. So the outcome of these random experiments are also not represented mathematically for our analysis. For example, random experiments such as tossing a coin. Here, heads or tail are not represented mathematically, but we have to analyze these random experiments which we have facing in our communication system. So we assign a number, or we can say a range of values to the outcomes of these types of random experiments. For example, in tossing a coin, outcomes head assign a value 1 and outcome tails assign a value 0. So these assigned numbers are called random variables and can be expressed mathematically. Or we can say that the outcome of any random experiments are assigned by a range of values or any real number which can easily analyze mathematically, called random variables. Also, random variables can also be defined as a rule which can assign a real number to each possible outcome. Random variables can also be defined in terms of sample space and random experiment. Here, random variable is defined as a function whose domain is a sample space and range is a set of real numbers. For example, again we take a random experiment of throwing a dice. Here there are 6 possible outcomes called sample points and their combination represent a sample space. Now, on the basis of event statement, we map these points to events A, B and C. Here A is an elementary event, B is a subset event corresponding to statement, that is even number of dot shows, and C is also a subset event corresponding to a statement, that is odd number of dots shows greater than 1. As these events A, B and C cannot represent mathematically and they are random outcomes, so we assign these events as a real number called random variables. So the random variables express as a function. For example, for event A, random variable is x function s1 or simply say small x1. Also for event B, random variable is x function s2, x function s4 and x function s6 or simply written as small x2, x4 and x6 respectively. Also for event C, random variables are x function s3, x function s5 or x3, x5. These random variables are a set of real numbers within a range minus infinity to plus infinity and corresponding to individual events, and the probability of all random variables must lie between a range of 0 to 1. Now we note a point. In any random experiment there are more than one random variables. For example, outcomes of event statement, that is even number of dot shows having sample points s2, s4 and s6 and correspond to this subset, we assign a random variables, that is x function s2, x function s4 and x function s6 respectively. So the process of assigning a real number to corresponding random events is called a random process. Here, a particular outcome or elementary event of any random experiment is denoted by small x. So the random variable in the form of function, that is x function sk, is assigned a real number, that is small x, and this is called a random process. Now the question arises, what is the advantage of using random variable? Since in any random experiment the outcome or event are not defined precisely in mathematical form, so the probability analysis require a conversion into a real value quantities called random variable. which can be analyzed mathematically. These random variables in the form of real value quantities are not dependent on the form or shape of any kind of events in any random experiment. So this makes a random variable suitable for any analysis process in communication system. Also, random variables are basically of three types. First is discrete random variables, which takes only a finite number of values. For example, in tossing a coin experiment, which is a random experiment. Here outcome head may assign a real number 1 and outcome tail by real number 0. Second random variable is called continuous random variable. In continuous random variable, the range of real values are assigned that is corresponding to the event. For example, amplitude of noise voltage at any time t. And the third is called complex random variable. The complex random variable is always treated as a vector of two real valued random variables that is correspond to real and imaginary terms. Now we discuss about probability mass function. Probability mass function is basically used to represent discrete random variables mathematically, and this is based on the concept of interpretation. Now let us consider an example of tossing a coin. In this random experiment, there are only two possible outcomes, that is heads and tails, and both outcomes cannot occur in a single trial. So the outcome head and tail is not a certain result, but in order to represent these results mathematically, we assign a finite number of real values called discrete random variables. For example, heads corresponding to random variable x equals to 1, that is a real number. Also, tails corresponding to random variable x equals to 0, that is also a real number. Now, as the probability of sample space, that is total possible outcome, is always 1, then the probability of occurrence of head and tail is just half. And this experiment based on discrete random variable is represented by a function that is called probability mass function. And it is denoted by p function x. Here capital X is called random variable having range -infinity to +infinity. And after assigning a real number that is a finite value, it is called small x. So p function x equals to small x is equals to half for x equals to 0, that is for tail, and half for x equals to 1, that is for head, and 0 otherwise. And the physical significance of this probability mass function is that it describes the probability of each possible values of random variables. That is, for the case of tossing a coin, we have two possible values having equiprobable of half. And to represent probability mass function, we have an infinite range of random variables in one-dimensional space, that is from -infinity to +infinity. And on this, we assign a two finite values of real number 0 and 1. For this, we use a delta function or impulse function of weight half at x equals to 0 and x equals to 1. And this represents a probability mass function for discrete random variables. In general, discrete random variable is represented by expression p function x equals to small x, and it is equals to 1 minus p for x equals to 0, p for x equals to 1 and 0 otherwise. Here x is a random variable that is called a Bernoulli random variable. Next probability function is probability distribution function. Probability distribution function is used to represent continuous random variable mathematically. For continuous random variable x, probability distribution function is written as f function small x, which means function is of a real value x, not a function of random variable x. And this is to be noted for probability distribution function. Now, this probability distribution function is very closely related to the probability mass function, which is represented by p function x equals to small x. Here the mass function is a representation of discrete random variable. So the relation between function of continuous random variable and discrete random variable is called a cumulative distribution function or CDF. Therefore, the cumulative distribution function is written as f function x, that is small x, and it is a real number, that is equals to probability function x less than or equals to small x. Here x, that is random variable, less than or equals to small x is called an event. So the event capital X less than or equals to small x having a continuous random variable capital X and small x as a real number. And here less than or equals to is an inequality. So the probability distribution function can be represented in terms of mass function with an event of x less than or equals to small x, and this is called a cumulative distribution function or CDF. Next, we talk about property of cumulative distribution function. Here f function small x is called cumulative distribution function, and the first property is the probability distribution function is always bounded between 0 and 1. That is, f function x is always greater or equals to 0 but less than or equals to 1. And the second property is based on the monotonic non-decreasing function of small x. That is a real number. Here, if x1 is less than or equals to x2, then the cumulative distribution function corresponding to x2 is always greater than or equals to the cumulative distribution function fx1. To explain the concept of cumulative distribution function, we consider an example of throwing a dice. This random experiment is based on set of rules. Here we consider a rule, that is x function si equals to phi I. Here si is called sample point and range of I is from 1 to 6. Here 1 to 6 is the total number of possible outcomes while throwing a dice. Now, according to this rule, if the outcome is 1, then the assigned random variable x is equals to 5. That is, we put I equals to 1 and the function becomes x function s1 equals to 5. Similarly, for outcome 2, random variable is 10. For outcome 3, assigned random variable is 15. For 4, random variable x equals to 20. For 5, x equals to 25. And for 6, x equals to 30. So the random experiment of throwing a dice with a rule, we can assign 6 random variables. Now, using the definition of cumulative distribution function, that is a relation between continuous random variable and discrete random variables, it is p function x less than or equals to small x. Here x less than or equals to small x is called an event. So on the basis of rule, the 6 possible outcomes of random experiment is assigned by random variables 5, 10, 15, 20, 25 and 30. Which means random variables less than 5 cannot be assigned as real number. That is totally based on the set of rule. And here we take a rule x function si equals to phi I. So for an event x less than or equals to 5, there is a probability of occurrence of only one dot show up. So probability of x less than or equals to 5 is equals to 1 by 6. Because here we consider equal probabilities for 6 possible outcomes. Similarly, for event x less than or equals to 10, there is a probability of occurrence of 1 or 2 dots. So the cumulative distribution function p function x less than or equals to 10 is equals to 1 by 3. And probability of x less than or equals to 15 is half. Here there is a chance of occurrence of 1 or 2 or 3 dots has come up. So accordingly we can find probabilities of rest of the events. That is, probability of x less than or equals to 20 is 2 by 3. Probability of x less than or equals to 25 is 5 by 6, and probability of x less than or equals to 30 is 6 by 6, or we call 1. Now, using the concept of cumulative distribution function and a set of rule, the distribution function can be represented graphically and based on the statics and interpretation. For real number x equals to 5, CDF is 1 by 6. For x equals to 10, it is 1 by 3. For 15, it is just half. And for 20, it is 2 by 3. For 25, it is 5 by 6. But for x equals to 30, the cumulative distribution function is equals to 1. Which means event x less than or equals to 30 includes all the possible outcomes of this random experiment, and its probability of occurrence is unity, hence called a certain event. In general, we can say that in cumulative distribution function, that is f function small x equals to p x less than or equals to x, here the event x less than or equals to small x may become a sure event as the small x tends to infinity. Now the probability distribution function is defined as the probability of occurrence of all the outcomes for which capital X is less than or equals to small x, and it is the relationship between the representation of discrete random variables and continuous random variables and called as cumulative distribution function. And accordingly, as the signed real number x tends to infinity, then the CDF value is equals to 1. And in this case, event x less than or equals to small x is called sure event. But when x tends to minus infinity, then CDF is equals to 0 and corresponding event is called a null event. So we can say that the CDF or cumulative distribution function is bounded between two values 0 and 1. That is, f function small x is greater or equals to 0 but less than or equals to 1.